Okay, so hi everyone, welcome to my channel. Today we will be doing, like you can see in the video, Chapter 9 Force and Laws of Motion, Chapter 2 of Physics Science. So the notes which I am showing you will be given in the description. You can get from there. So let's understand this chapter completely, and this is the full video explanation. So let's understand. What do you understand by force? What is a force? Okay, so the full chapter name is Force and Laws of Motion. We will be learning all those, we will be dealing with everything. But first of all, what is a force? Force is a push or a pull. Is a push or a pull on an object that produces acceleration in the body on which it acts. So what we're doing? So what is it? Force. What exactly is the force? The force is push or a pull. You are pushing an object or you are pulling something. Okay, an object or something, whatever it may be, which creates an acceleration. Acceleration is what? There is change in is initial velocity and final velocity, right? So if the initial object is 0, means rest, and when you're applying some force, it when you're applying the force, the velocity is changing, and so the acceleration is causing. So what is a force? You can say force is a push or a pull. Push or a pull applied on an object which creates an acceleration. So what is the SI unit? SI unit is Newton. 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 Force is Newton. So what you can say, what are the effects of force? When they ask in the question, what are the effects of force? You shouldn't be blank, right? What are the effects? What can it do? It can change the position of an object. It can move an object from rest. It can make the body rest from moving. It can change the speed, direction, shape, size, anything. So like what is happening? You have a playing clay. When you're applying the force, you're changing the shape of it, right? And size also, like take a sponge, and when you apply some force, it becomes so small. So we're doing something, you're changing the shape, size, speed, changing from rest to motion, motion to rest. So there are many effects of force. Now force are basically of two types: balanced and unbalanced forces. Balanced and unbalanced forces. What is balanced force? What is unbalanced force? We'll be dealing with all those. So what is balanced force? If two forces act on an object in opposite direction, and if both the forces are equal, then the resultant force acting on a body is 0. Such force is called balanced force. Remember this. So what is happening? When two or more forces act simultaneously. Okay, now you can say that's the resultant force. Okay, let's see this. Now there's an object. Okay, you and your sister, or you and your brother, they are pushing the object in opposite direction. If you're doing from north to south, they're doing from south to north. It's like the opposite direction. So what is happening? The body is not moving. Okay, it is equal. Your both forces are equal. Then you can say unbalanced forces. You can say that if force is acted on a body, and if both forces are equal and the body is not displacing, the force acting is 0, then it is said to be balanced. Coming to unbalanced, what is unbalanced forces? When force is acted on body, and whatever force you're applying, think you're bigger than your sister or brother, and you apply more force. So what is happening? The object is moving towards your brother or sister. So what is happening here? Here the force is not equal. Your force is greater than your opposite ones. So what is happening? It is moving. Okay, so what is happening? When the force is acting on an object in the opposite direction. Okay, if one force is greater than the other, then the body displaces. It is said to be in unbalanced forces. I hope you've understood. Third one is force of friction. Now I'll give you an activity you can do right now. Keep your phone down and rub your both hands. Let us do together. Oh, what is creating? Heat is creating, right? We are applying a force. We are applying a force on our hands which causes heating, right? So what is happening? We are doing force of friction only here, right? What is force of friction? It is force which opposes the motion of an object. Very important. Write in your book, force of friction. What is force of friction? Force of friction is a force which is applied on opposite on which the motion of an object is moving. If the object is moving from right to left, friction will happen from left to right. If the object is moving from left to right, the friction will happen from right to left. You can just say it's like opposite. So force of friction is a force which acts opposite, which, or you can say, which opposes the motion of an object. Okay, so what is an example? Now if you throw a ball, okay, it stops. Why? Force of friction is also acting. Think, you say that friction is not so good. Some members think that, right? If you think it is good, great. But if some members don't think, we are able to walk because of friction only. Think, friction is not there in the world, okay, how you can imagine that? Ice skating. Can you stand on that ice skating ground without those skatings? No. And for skatings also, you need to practice how to stand on the ice, or else you'll fall. So on the ice, the friction is so less that you're not even able to stand. So you can think force of friction is very, very important. Galileo's experiment of motion of an object. So when marble rolls down in an inclined plane, the velocity increases, you can see, right? But when it is moving from down to up, okay, it's not. And when you are changing each and every time, the height is remaining the same, but it is displacing more. So it is Galileo's experiment, but if you didn't understand, you will further understand it. Because of this Galileo's experiments, Newton created some laws. Okay, Newton used Galileo's experiments and he created some laws, which he named Newton 3 laws. Like, he have totally 3 laws of motion. Newton law 1, first law, second law, third law. First law is also called law of inertia. Law of inertia. First law of motion is also called, Newton's first law of motion is also called law of inertia. Now, what is Newton's first law of motion? What does it exactly say? An object remain in a state of rest or an uniform motion in a straight line unless compelled to change that state by an applied force. Okay, good. So let's understand. Okay, so let me say in simple words, an object will stay in its rest or uniform motion if no force is applied. Or let's take an example. Okay, here you have books beside you and the books are in the rest. When you apply some force, it is changing, right? But again, you don't apply the force, it will remain in rest. Or take an example, there is a vehicle. If you're applying more, what we say, that okay, when I'm applying more force, it is moving more faster, and when I stop applying force, it remains in uniform motion. So what we are doing, an object will stay in its position of rest or uniform motion if no external force is applied. So you understood. It is also called law of inertia, right? Now, what is inertia? Okay, like I gave an example of a book, of your book. You have a science textbook beside you, science notebook beside you, and you're writing down the things, right? So there's a science textbook beside you. Now this book is not even moving. Think, when we apply a force, it moves, right? Okay, and when we're not applying a force, okay, it is just being in rest. The book, I'm talking about the book. Why it is happening and how it is happening, why it is in rest and why it is not in motion. This is what inertia is. Inertia is natural tendency of an object to remain in its position of rest. Means of it is a property. It is now we think a lazy person is there, okay, until you push the person so hard, scold so hard, he or she is not going to do any work, right? It's a tendency. It is his property or her property to remain in rest until and unless you say anything, you do anything, you scold him or her. Okay, so what he's doing? He's remaining in rest. That's what is inertia is. It is natural tendency of an object to remain in its position of rest. So it's like when you don't apply a force, an external force, it is its tendency to remain in rest. I hope you have understood. I have tried to explain, so let's go further. Shall we give examples of inertia? If a striker hits a pile of coins on a carom board, right, the lowest coin moves out due to inertia of rest and the other coins fall down. If a coin placed playing hardcover over a tumbler is flicked with the finger, due to inertia of rest, the coin falls down into the tumbler. When we travel in a car and driver applies brakes suddenly, we tend to fall forward due to inertia of motion. So there are two inertia, inertia of rest and inertia of motion, as you can see. So inertia of rest is like, first example, let us see the first example. When the striker hits a pile of coins, it was in rest, right? And suddenly it got into motion. That's why it fell down. So what is happening here? Like this one, as you can see this one. Can you see the diagram down? How what they are doing? It is because it was in rest. And suddenly, when you just pushed the card, it just went inside. It's because inertia of rest. Now, let's take an example. It happened all suddenly. If you have done slowly, it would have not fallen in the glass. It would have fallen down. Let's take an example of fan, okay? When you on the fan, what is happening? It is starting slowly. It is starting slowly and it is increasing time by time, and finally it decreases the fast. It is not happening suddenly. Suddenly it is not being fast. Slowly. It happens slowly. Now take an example. If a person applies a brake slowly, then nothing will happen to you. If the person applies the brake like suddenly, what happens? You move forward. Why? It is because of inertia of motion. So I hope you are able to understand. Inertia and mass. Okay. So there is a relation between inertia and mass here. Body at rest continues to be at rest, right? What is the inertia? That's of it's a tendency of an object to remain in its position of rest. So a body at rest continue to be at rest, okay? And a body in motion continue to be in motion. This is nothing but inertia of rest and inertia of motion. Inertia of a body is measured by magnitude of force required to change the state of a body. Now think, when we are applying a force, what is happening? There is a displacement, right? Okay, and there is a mass. So when you need to apply more force to heavier mass, and you need to apply less force to lighter mass, right? So the force required to change one state of a heavier object is more than the force required to change the state of lighter object. This is because mass of heavier object is more than the mass of lighter body. So the mass of body is measure of its inertia. So think, inertia is directly proportional to mass. Why? Because you need to apply more inertia in order to. Why? Because there is more mass, right? So more mass, more inertia. Less mass, less inertia. Now momentum, which most people have problem in. What is momentum? Momentum of a body is product of its mass and velocity. Okay, so what is momentum? Momentum is or else this is just a formula, right? Momentum is actually the amount of motion contained in an object. So amount of motion contained in an object. So as you can see, mass, velocity, amount of motion contained in a body, right? Motion, velocity, mass, simply mass. So moment is mass into velocity. Momentum we denote it by P. So where P is momentum, M is mass, and V is velocity. If a body is rest, its velocity is 0, so momentum will be 0. Think, if mass is 0 or velocity is 0, probably momentum will be 0, right? SI unit of momentum is kg meter per second. Okay, now let's take an example of momentum. A truck moving at very low speed can kill a person, right? And it's powered because of heavy mass of truck. So, think, if mass is low, velocity is low, then nothing will happen. But mass of truck is very much. Now, let's take an example of a cycle. Okay, if a cycle moving with low speed, okay, hits a person, it is not going to kill the person. It can hurt but cannot kill. Why? Because mass is less, that's why. Now momentum is related to second law of motion. Okay, here Newton's second law of motion says that rate of change of momentum, remember, rate of change of momentum is directly proportional to net external force applied. What did I say here? Rate of change of linear momentum. So what is change of linear momentum? It is Pf minus Pi. final position minus initial position. Final momentum minus initial momentum. Now the rate means time by t is directly proportional to applied force, means F. So as you can see here, initial momentum is P1, means mu, final is mv. So mu minus mv, okay, is F. So mv minus u by t is F. V minus u by t is what? It is acceleration. So ma is directly proportional to F. If you want to remove the proportional, you need to add constant. So F is equals to kma, or simply you can write F is equals to ma. So you understood here Newton's third law of motion, which is so interesting. Okay, to every action there is equal and opposite reaction. Very important and easy, right? So whatever action you apply, there's gonna be equal and opposite reaction. Now you will be asking, okay, we are applying the equal action and reaction is also happening equal. Then why it is not destroying, why it is happening? It is because action applied on a body is different from reaction happening on a body. Like say it is going to destroy only when the object is same, right? Now think balloon, you have blew a balloon with some force, and when you leave the balloon flies, right? Okay, then what is the reaction? Action is what? You are up, the balloon is flying up. What is the reaction? The air is coming down. See, here action is on balloon, but reaction is on air. Both are different objects, different bodies, right? So how can they destroy? So they act on different bodies. That's why they don't don't destroy. So you can say to every action there is an equal and opposite reaction. This example is very, very important, the gun one. It can come in exam for sure. So let's see this example of action and reaction. When a bullet is fired from a gun, it exerts a force on the bullet, and bullet exerts an equal and opposite force on the gun, and gun recoils. So what is happening here? There is a gun, okay, and when a bullet is fired from gun, okay, when you're firing a bullet from a gun, it exerts a force, forward force, of course, action. So what is happening? Bullet is moving forward. So action is on bullet, and opposite force on the gun, right? Gun recoil of gun, there is an opposite reaction. So it's on different body. Action is on bullet, reaction is on what? Gun. Okay, I gave an example of balloon, right? Similarly with rocket also it happens. Conservation of momentum, very, very important. It's really very, very important. So do listen this. Conservation of momentum. What is conservation of momentum? Law of conservation of momentum states that sum of momentum of two, sum of momenta, it is plural form of momentum. So sum of momenta of two objects before collision is equal to sum of momenta after collision, provided there is no unbalanced forces acting on them. So what exactly it means? That it means that sum of momentum before collision is equal to sum of momentum after collision. So mu will be equal to mv. So there's a two object, right? Like I said, it happens on two different bodies. So as you can see, AB, MAUA, MBUB. When they collides, then MAVA, MBVB. So MAUA, MBUB before collision and MAVA, MBVB after collision, both will be same if there is no external force applied. So I hope you understood. So sum of momenta of two objects before collision will be equal to after collision. So I hope you have understood. This was simple. What simple? It was simple and easy to understand. Change in momentum of a ball during collision. What is happening? MAVA minus MAUA. Yes, right? Rate of change in momentum is T will come. So MAUA by T. Rate of change of momentum. So according to that, MAVA, minus MAUA equals to MBVB plus MAUA. MAUA minus MAUA equals to MAVA minus MBVB. or MAUA plus MBUB is equals to MAVA plus MVBB. So the red line, as you can see, the red one which is highlighted, do keep that in your mind, which is MAUA plus MBUB. They are two different objects, okay, which will be equal to MAVA plus MVBB. Got it? Momentum of two balls before collision, not only balls, it can be anything else. It will be equal to momentum of two balls after collision. Okay, so have we completed? So everyone, finally we have completed the chapter. This was such an easy chapter and just we completed it in 20 minutes. Thank you so much for watching the video. This was a one shot with detailed explanation. Do share it with your friends because it didn't take much time to explain and we explained every topic. So thank you so much. This is N.R.M speaking and thank you so much for watching the video. Do like, share, subscribe to my channel. Share with your friends to provide motivation, some tips and of course studying art and life. Thank you so much for watching. Meet you in your next video. Thank you so much. Share with your friends, like and subscribe. Bye.